Hello, welcome to the McDonald Observatory live stream. Oh wow, I see there's a lot of people watching today. Well, welcome. So my name is Saul Rivera. I'm a public program specialist up at the McDonald Observatory, which is a research institute of the University of Texas at Austin. And so happy y'all could join us today. This is going to be a really cool, exciting event. So for if you haven't joined any of our streams before, so as you can see, the layout we're going for this stream is going to be a very special one. So basically, what I'll be doing is the stream will be going on for about 2-3 hours or so. I'll be jumping in and showing some really cool different things. So, well, more cool different views if weather applies, if it's cooperating, because it's kind of iffy weather. We'll be showing live views through two telescopes. We currently have one from the McDonald Observatory back at home base. Well, not home base for the observatory, but home base for me. I'm currently visiting family in Irving, Texas, in the Post-totality because I really want to see this eclipse. And the other one, which has currently been clouded out, is the one over here, Lake Buchanan in Austin, Texas. So so you can see a bit more of the layout again. So here's our live stream going on. So basically we're right now doing an intro, and about every 20 minutes or so I'll be jumping in. Oh, the Lake Buchanan's view has come back. Every 20 minutes or so I'll be jumping back in and kind of talking about relate eclipse things, such as what cause eclipses, how to see them, how the historical significance of eclipses, and other similar things. And kind of apart from that, kind of want to give a little kind of small introduction. Lots of people were very excited for this event, and even here in Texas, like even the little video my mom had taken just trying to run some early errands that she had found is from people all over Texas and the U.S. just really excited for this event. It's going to be super cool. Next eclipse in the U.S. won't be till 2045, so I'm really hoping the clouds clear up. It's, as you can see from the video, we are pretty overcast right now, and yeah, it's going to be really cool. We're having people from all over visiting Texas. There have been some reports that DFW is going to get about 400,000 people. That Austin's might be almost double the population in terms of visitors. It's going to be such a cool event. Some other little things, as you can see, there's already some people there. My mom took this video about an hour and a half ago, so I'm pretty sure there's a lot more people there now. And depending where you're watching from or where you are while you're watching this, would change the actual time you're seeing the eclipse. So some other little things I want to talk about is kind of some of the other stuff we have set up, such as the telescope we're using, so kind of more information about what we're seeing. And also kind of more specifically where we are on maps and such. So here is where we're kind of currently located. All of us are kind of joining in on the stream for tonight, us employees of the McDonald Observatory. So the orange star is where the McDonald Observatory is located, out in Fort Davis, Texas, very far west Texas. And that's where our live stream is coming from, the McDonald Observatory one. It's with our solar telescope on site, which is currently it's looking at the sun, the H alpha or hydrogen alpha view, which is also why the sun looks pretty weird right now. Or not weird, just looks a little different. So we're seeing a different wavelength, so we can see some different aspects of it. The other view we got going on is from Lake Buchanan near Austin, Texas. They're kind of getting some clouds here and there, so you're seeing the views kind of coming and going from them, as can be expected. One of my colleagues is there with his telescope set up, and every now and then might send pictures of how it looks like there at that location. And the green star is where I currently am at Irving, Texas. So hopefully we'll get clear skies as we're hoping for. Even if the skies don't clear, we'll be getting some really cool views going on. And so just kind of some of the views I want to talk about, apart from the live telescope views, is kind of, if also weather complies, I'll be setting my own phone there. And also, even if it is cloudy, you will still be seeing some really cool things. So it's basically becoming nighttime, middle of the day You're going to see the sky darken. You're going to feel temperatures drop. Even without cloud cover, you'll still be experiencing those events. Kind of talking a bit more about where I work at, the McDonald Observatory. We, as I said, we're in far west Texas, out in the middle of nowhere, which is very good for research astronomy. You can see Lake Buchanan view is back. This here pictured in the this pictured is the visitor center, where you hold public programming. People from all over the world come to visit. We've had many people from out of the country visiting us this past week, from UK, Germany, Netherlands, Dublin, California. California is very far away, for me at least. And the telescopes in the back are some of our research telescopes here. Now, a bit more about the telescope we're using for the McDonald Observatory view. We have some solar telescopes set up, looking at the different wavelengths. We have a 6-inch, 3-inch, and 2.4-inch refracting telescopes. We are currently using one of the ones with the H alpha view to get this cool view. That, by the way, both of these views above me are live views of the sun. And the past, here are some of the past kind of going on. So you've over the 2017 one already passed. The air one passed a few months ago, and now we're at the total solar eclipse. So cool. Here's just more zoom in of where you are in Texas, where you can see this total solar eclipse. You probably have an idea of it with all the news reports and such going on about it. But yeah, it's going to be a very exciting program. Can't wait to kind of show you all these cool views of the sun. And I'll be coming back in a couple of minutes to talk about how eclipses occur. Oh, welcome back, everyone. So, if you're just joining in, welcome to the McDonald Observatory live stream. My name is Saul Rivera. I'm going to be showing off the eclipses today. As you can see, spin it backwards. The observatory view is already starting to get a partial eclipse. Their partial eclipse starts at about 12:09. The one in Lake Buchanan will start. Should be starting a little bit now, probably. Kind of like probably on the other edge, but they are getting some issues with clouds coming in and out. May thankfully not be thick enough to block out the full sun, but for the telescope, it will be causing some issues. So first, I'm going to show off kind of like since we're starting to get some of that partial eclipse view going on. I remove this kind of little setting I got going on. There it goes. Now it's a lot more accurate. It is because it is showtime. The counter was kind of for start of eclipse, but they've already started. So at least not the full show, the totality, because it's gonna be a while for that. But at least now you can see that part going on. So again, for those of you just joining us, this is a live view of the sun from the McDonald Observatory and the H alpha hydrogen alpha view. And that kind of piece that seems to be being bitten out of the sun is the moon. The moon is blocking out some of the sun's light right now. And that just looks so cool. So if you can kind of go on so depending where you are in Texas, this will start at different points. For me, over here in Irving, Texas, it won't start for another a few minutes before we start getting any parts of the sun covered up. Also, of the telescopes we have currently at Lake Buchanan is this one here. It's an 8-inch telescope. Currently has that setup going on with a camera from the McDonald Observatory, kind of where the eyepiece should be. That's actually the setup we do for some of our other streams. We have a camera sub where the eyepiece is, so you can see what the telescope is seeing. And that's a pretty nice solar filter going on, so we can actually see it. It's gonna look really cool there. My colleague said Lake Buchanan, so basically they're gonna see the eclipse kind of going over the lake. It's gonna be so cool. But talking about eclipses, something we get asked a lot is how do eclipses actually happen? So the reason eclipses happen, be it solar or lunar, is because of the moon's orbit around the sun. So where we are orbiting the sun, got a little tongue there. Not the moon's orbit around the sun. If the moon's orbiting the sun, that would be very bad. The moon's orbit around Earth. So Earth is orbiting the sun, and the moon is orbiting Earth. So kind of have a little video kind of showing that in action. And as you can see, so and on the pencil to be our moon. There it is. Hello, past me. So there we're gonna have to start. It has a little smiley face on it as well, so you can see the face of the moon that's always pointing towards us. So the moon slowly makes its way around the Earth. So also this is what causes moon phases. So currently right now I can see only a small portion of the moon is currently lit up. So when we first started off, we were at new moon. We were basically the only half. So to backtrack a bit, uh, half of the moon is always lit up by the sun's light. But as the moon makes its way around the sun, that we see different areas getting lit up. So at new moon, we aren't seeing any of the lit up areas. Right now, as it starts making its way around, a small portion is lit up, which will be the crescent moon phase, which we got going on. Let me restart the video. Go back a little bit there. We got a crescent phase. Then it's going to keep on going to half moon, or better yet, first quarter moon, because half it's lit up in its core way through the cycle. Then we got what we call the gibbous moon. So that's kind of that weird egg shape you're going on. This will be waxing gibbous. The thing that can help you remember it is waxing makes things shinier. So it's getting shinier. The moon is waxing. And then when it's completely illuminated, we see the full illuminated side. It's a full moon. Now, as the moon makes its way around Earth, it isn't always at the same plane. Sometimes the moon can be a little bit higher up, sometimes it can be a little farther down, and depending where it is, can also lead to another event. So sometimes If the moon is low enough, it can actually go into Earth's shadow. When it goes into Earth's shadow, that's when it gets a lunar eclipse. So kind of continuing back through the cycles, we're starting to continue to make a way around. Now we're at the waning phase. Keep on. We're at the third quarter, another half moon. Ooh, Lake Buchanan, you can get that partial. Then we're at the crescent, and we're back at new moon. Though sometimes the moon can line up just right, as I said, showing here in the video, it can be a little bit above, a little bit below, but it's right the center. It can completely block out the sun's light, giving us a total solar eclipse. Now, the reason we don't have a total solar eclipse now, like the whole Earth is plunged into darkness, it's just a small area, is that the moon's shadow only lands on a small part of Earth at a time. So when I took this video, you can see here. So one eye is experiencing a total solar eclipse. The moon is completely blocking out the sun's light, and it's making that area plunge into darkness. The other eye, though, is currently looking at getting full sunlight. It's looking at the sun, and thankfully, this was a quick picture. If not, that eye will start hurting a lot after staring at the sun at this star light bulb for so long. Not the sun. Do not look directly to the sun. If you want to look directly to the sun, make sure you have something like one of these laying around. Oh, it looks cool with a little green screen effect. This is a white ones, but now we got like cool. Oh, that's so cool. Kind of like a little cool effect going on with the light shining off of these. But kind of going back to what I was saying, so the only one part of the Earth is currently having that shadow go on. That part of it's the shadow is that total solar eclipse. And actually, when you see it's like from very high up, like here's a video again, kind of showing that into more detail. So there we have this was the path of the 2017 eclipse. So as kind of that shadow's making its way across, is where we were getting that path of totality, which we call it. The very dark circle you're seeing in the video is actually the eclipse. That's where you would have a total solar eclipse. So, and there's different parts to the shadow. So the really, really dark part is called the umbra. The not as dark is the penumbra. So the umbra areas will be getting that total solar eclipse. Penumbra, like our colleagues back from McDonald Observatory, are going to get what we call the partial eclipse. And this how it looks like from the International Space Station. This is how a total solar eclipse looks like on Earth if you were seeing it from up at the International Space Station. So you see the really dark part, that would be where we got that total solar eclipse going on. And the not as dark part is the penumbra, which is the partial eclipse. Because there are different types of eclipses. So what a lot of the U.S. will be experiencing, so kind of almost anywhere in the U.S., you will be seeing a partial eclipse. The moon is only partially blocking out the sun's light. The closer you are to the path of totality, the more and more of the sun's light will be blocked out. And for McDonald Observatory, that will be like about 91%. The further away you are, the more and more will be blocked out. The opposite. The further away you are, the less and less will be blocked out. But what we're experiencing, as sometimes what can also happen, is what we call an annular eclipse. So those that might have been in Texas and some other parts of the U.S. in October of last year experienced some of this. So also apart from the moon signs being a little bit higher, a little bit lower of the plane of it's going around the Earth, signs can be a little bit closer or a little bit further away. Sometimes the moon can line up just right as if it was going to almost be like a total solar eclipse, but the moon is just slightly too far away to completely block out the sun's light, which gives what we call the annular eclipse, also nicknamed the Ring of Fire. What can also sometimes happen, which is happening like today, is the moon completely blocks out the sun's light, giving us a total solar eclipse. And that kind of bright light you see around the moon right now in the eclipse is what we call the sun's corona. It's our most dimmest layer. And also, once the sun starts reappearing again, a little bit of the sun's light kind of pokes on through and gets this kind of like really cool like diamond effect going on. And as I mentioned earlier, lunar eclipses also happen. They happen a lot more frequently, kind of on the sense that, hey, it's kind of easier for the moon to go into Earth's shadow than for it to block out the sun just right to have that total solar eclipse. And the reason it gets that reddish tinge during a lunar eclipse is sunlight's kind of going through Earth's atmosphere and getting that reddish tinge going on. So here's some really cool views from my colleagues going on. Yeah, so that's kind of the wraparound of how eclipses actually happen. Let's go kind of zoomed in view of our live views. So you can see the Lake Buchanan view is currently looks really nice. We got some light clouds going on, but but not too much, thankfully. They seem to be up and clearing as the time goes on, which is really nice since we're expecting huge swing for a lot of Texas, so it seems it's kind of cooperating right now. Hopefully that keeps on going. You also they got some wind. My colleague over there, Ryan, he actually did say like, hey, there's kind of some wind going on, shaking up the telescope. So you can see that here. You can see these sunspots, the dark spots on the sun currently. They are cooler areas of the sun. This sunspot right about here. Oh, my cursor doesn't appear. Well, I'll fix that in a bit. But kind of like some of the smaller sunspots. These sunspots are basically multiple times larger than planet Earth. And oh no, the clouds are coming and going. Thankfully, they're just thin clouds, and I just messed up the view, and are not actually blocking out the sun for him. And now going back to the view from the McDonald Observatory, there we got that really cool view going on. There you can see like the moon is slowly encroaching on the sun. Oh, it looks so cool. I can't wait until it reaches showtime or until it reaches the peak. But that won't be for another about like for me at least like almost over an hour. For Austin, that'll be in about an hour. But yeah, so I'll be jumping back in a couple of minutes, about 12:40, to talk about how we can actually see these eclipses. So it doesn't matter if you're in path totality or not in path totality, you need to have safe solar viewing. So I'll catch y'all again in a couple of minutes. Welcome back, everyone. So, if you're just joining in, welcome to the McDonald Observatory live stream. My name is Saul Rivera. I work for the McDonald Observatory out in West Texas, and we're kind of getting ready for the total eclipse today, which I'm really excited about. Now, you might be wondering how to actually see the eclipse. Hopefully, you've been getting eclipse viewers and such, but let's say you weren't able to get one in time, or trying to find out what will be the best way. Or you might be thinking it might not be worth to check out the eclipse if you're not in the path of totality. So even if you're not in the path of totality, you can still get a partial eclipse. Kind of like the views we're getting right now from both of these telescopes. These are live views from the telescope. We got one from the McDonald Observatory back in West Texas. They're going to have their partial eclipses kind of going in. We have the H alpha or hydrogen alpha view going on. You're seeing more of the sun's light getting blocked out by the moon. And also one from, well, we had a view from Lake Buchanan. Oh, there it goes. It's coming back. Right on cue. From a solar telescope out there in Lake Buchanan near Austin. Now, to actually see these eclipses, so there are different ways to actually see the eclipse. So one way is with projection. So the picture, the object in the red is actually a small telescope. The light is coming through the front, coming out the eyepiece, and it's being projected onto a piece of paper. If we get the paper too close and the sharp is too sharp as it's getting close, that's when we can start things on fire. We do not want that. You can also look at the sun directly with a telescope, but make sure to have a proper solar filter on there. If you don't, it's going to be really, really bad. Because telescopes basically are focusing light. They're acting like a magnifying glass. So you don't want a magnifying glass with the full concentrated power of the sun going directly into your eye. So make sure you have a proper solar filter on that telescope. But say you don't have a solar telescope. The other way you can do it is with proper viewers. So there's eclipse viewers and eclipse glasses. So we got some eclipse glasses here, which currently, because of the lighting in my kind of green screen going on, is giving this really cool, almost like a video game effect, you can say. Kind of like, oh, I've got a new drop, but a new pickup for my inventory, which does fit here. Or you can also get some little eclipse viewer cards, like the ones attached to this piece of paper. So these viewers have a special film on them that's blocking out a lot of the sun's light, like 99.9% of it, making it safe to look through these viewers without damaging your eyes. Also, if you're trying to take pictures of the eclipse, do not point your cameras or phone cameras directly at the sun. That can damage the equipment because you're, again, focusing the light into that small point. But if you kind of have your phone and put up your viewer up to the camera area, you are able to take some safer pictures like that. Once it reaches totality, that 100% of a sun's light's being blocked out, that's a point where you can remove any viewers and look directly at the eclipse, or directly take pictures of the eclipse. Another thing you can do, kind of there, because we do have some younger astronomers in the audience, or just families from all over. Actually, some family and friends are currently visiting me here, and one of the people coming along is a 2-year-old. So with a 2-year-old, you get one of these glasses. They're going to look up, be like, that's really cool. But they're going to want to peek on over, peek on under, trying to get views of the sun, which again is very bad. And by this case, views of the sun is unexposed views of the sun. So what sometimes we can do is you can get just a regular piece of paper plate, cut a hole into it. Again, this is just getting a really cool effect because of the lighting and the green screen. But we cut a little opening in the viewer, cut a little triangle for the nose, and tape the viewer to the back. And now you can have your little ones can look up at the sun safely without accidentally peeking out over the sides and damaging their eyes. Also, one of my family friends that's visiting, she was playing around with this. I let them borrow this so they can check it out. And she actually preferred this method because it also acts like a shade. So she isn't taking the full sun's light. She's just looking at the sun while staying in the man-made shade. The other way you can view the light is through pinhole viewers, or basically a pinhole effect. So the light goes in through a very small area. I can get what we call a pinhole effect. And as the sunlight's getting blocked out, you can notice the kind of the eclipse shape going on. So kind of the picture on the right is from NASA during you can see during the eclipse there, how light's filtering in through the rooftop of small little holes. And all, instead of lots of little white circles, you're getting lots of crescent shapes going on. You can also use this with your hands. So just if you kind of do your hands like in the kind of net pattern and put it like near the floor, the sun's light can filter through and get that kind of pinhole effect going on. Also, you can, if you have a 3D printer lying around, you can print some 3D viewers. Let's see. Aha, this one might be better one. So you guys got some little cats going on, and try to put them up to, let's see, hopefully the light. There you see, you're seeing the eyes kind of shine on through. So these are 3D printed cats, and has some small openings of the eyes. So with a pinhole effect, we hold it up to the ground. You see the sun's light kind of shining through, and it'll kind of look like the cat's getting sleepy because as time's going on, the eyelids are going to be closing, which is the moon blocking out some of the sun's light there. You can also what one of my colleagues did is she kind of little paper cat cutout. So with a little paper cat cutout, she actually made me make myself bigger so it'll be easier to see these. So here's the 3D printed cats. And here's the paper cutout my colleague made. So it's just with regular black construction paper. She found this really fun template online of this little scaredy cat. And with a little hole puncher, was able to make those eyes. So we go outside and kind of put it onto the floor. The shadow, you can see kind of that little effect going on with it. Which I actually, since I'm planning to go outside later on and when it reaches totality, I'll try to do that. See if I can show some of this. Now, let's say you don't have your construction paper, you don't have the 3D printer lying around, you don't have the viewers. You can make your own pinhole viewer using a cereal box, some tape, something to make a small hole, like a little push pin or a hairpin, something like that could work, some scissors, and some aluminum foil. So what you'll get your cereal box and make, it's blocking out the QR code. You can never find out it's here. But you can make a small opening, so a small cutout, like about an inch square is kind of good to the top and to the bottom. So I'm going to try that out. I kept it open so it'll be easier to make that cut. Let's see. We didn't expect for this to be an arts and crafts stream, did you? Hey, that's what makes it fun. That's what makes science fun, kind of building things on your own. So then I'm going to kind of make it so it's about an inch opening. Also, these streams do have some playback. So if you want to go back and watch this, you definitely can. Let's see. So we got our little holes cut out. I'm going to put some tape to keep this area together, just for extra safety. You want to be very safe in science if you can. I know usually shows mad scientists blowing up, and even though that is fun, you have to be safe during that. So we got a little openings going on. So in one of the openings, I'm going to choose the top opening. I'm going to put a little bit of aluminum foil there. A very small piece of it. Fold it in half. I actually ripped it, which is a good thing. I have more pieces. Just gonna cut it to avoid more rippage. Or more tears, probably a more accurate term. Put it on the opening. And put some tape down to make sure it doesn't get blown away by the wind. So there is some light wind going on here and there. There we go. We got aluminum. We got our opening. Now next, the only thing left to do is get our push pin, go to the opening, and just one small push in the center. So what you can also do if you want to kind of make a cooler effect is at the back of the cereal box, you'll put a piece of white paper on the inside, and I'll give a better view. And you've now made your pinhole viewer. So the way this works, the light's going to come in through the top where the aluminum is and do that pinhole effect on the back of the cereal box. And this bottom area will be where it'll be looking through. So it'll kind of be looking like this, with the sun being behind you. So instead of kind of looking like this will be more accurate. Sun will be behind me. I look through the opening, and we'll get a cool pinhole effect at the bottom of the cereal box. It's a fun arts and crafts thing. You can get really cool effects, and you can do this regardless of there being an eclipse or not. So let's see. Let's go switch back to our live view, see how those are going. It seems there might be getting some light clouds over at the observatory, and also at Lake Buchanan. Hopefully those clear up. Oh, wrong button. There it goes. So I'll be joined. So hopefully this was helpful. I really hope you are checking out the eclipse. Again, even if you aren't in the Post-totality, you can get some really cool views. Actually, which reminds me, there's something you can check out. It's actually in the description of our. It's in the description here. Also, if you're hearing my keyboard, the click-clack sounds, that's my keyboard. Makes me feel productive. But in the description here, find a link that I put on, which is the path of this eclipse. So kind of switch on over. So again, this is linked in right now in the description of this video, and they're showing the path of today's eclipse. So if you want, you can actually type in where you want to be. So let's say, I type in Irving, Texas. I can see how I can see what amount of the eclipse I'm getting. You can also just zoom in and click the area. So for me, right now I'm currently visiting family in Irving. So kind of what we have here is showing the path, the timing of the eclipse. So in here is showing that the start of the partial eclipse, once the moon is finally starting to block out some of the sun's light, was at 12:23. The start of the total solar eclipse, which is the one I'm looking forward to, like I said, it's going to be 1:40. It'll reach its max basically when the moon is the dead center on the sun, will be around 1:42. At 1:44 is when it will end, and the full partial aspect of it is going to end kind of getting closer to about 3 o'clock or so. So, but again, I said if you're anywhere in the U.S., you can almost anywhere in the U.S. you can see this. So let's say I have friends in Seattle. They will be getting a partial eclipse. I can actually see the amount that get blocked out. It will be about almost 20% of the light will get blocked out at the max. If you're, let's say, in the Bahamas, at the max, you'll be getting about 38%. I have also some friends over in DC. They're going to get about 84%. Back at the observatory, they'll be getting about, I may have shot the mark a little bit here, but we're getting about 91% of the light blocked out. So no matter where you are in the U.S. today, excluding clouds getting in the way, which is an astronomer's worst nightmare, you kind of are now seeing how astronomers feel when weather is iffy for us. But you can see the partial eclipse effect going on. It's going to be really cool. So yeah, so I'll be jumping back in a couple minutes to talk about how eclipses have been working through history. So you can learn some cool new facts about eclipses. See y'all in a bit. Welcome back, everyone. If you're just joining us, this is the McDonald Observatory live stream for today's total solar eclipse. We've been talking about eclipses, how they happen, how to see them, getting ready for that total solar eclipse for some of us. So I do have live views here. So we have one from the McDonald Observatory. Currently, it's through a solar telescope there on McDonald Observatory site near the Visitor Center. We are going to have a partial eclipse up to about 91% of the sun side will be blocked out. We're getting close to that maximum point. And also this in the H alpha hydrogen alpha view, which the sun looks a little bit weird. We also have a telescope over at the Lake Buchanan. And for that one, for that telescope, it's going to, they're having a little bit of issues going on, but apart from that, yeah, they will be getting a view coming by at some point. Again, they've been having some views again, so just gotta wait for technology to behave and kind of work with the pointing and for weather to cooperate as well. As I said, we've been talking about how they happen, how to see them, but how long have we known about them? So eclipses are a thing that's been happening on Earth for a very, very long time. And people have seen them for basically since all of human civilization. And there have been many stories about what eclipses can be. Some have seen that eclipse can be like an aspect of like omens, for example. Some thought meant the world is ending. Some astronomers, like those in ancient China, believed the moon was a dragon was trying to eat the sun and the moon, and they would actually play drums to drive that dragon away. Actually, one of the first records of this happening was about 2150 BCE, when some astronomers named Ho and Hai had failed to predict that an eclipse was going to happen, and the emperor was not happy about that. Actually, Babylonian astronomers also had a really good idea of the motion of celestial objects. So when you have a really dark sky and I can see the stars and the planets and the moon and sun very easily, you can spend a lot of time tracking them. They actually were able to follow these movements to such a measurement that they predicted about every 18 years and 11.3 days, that 0.3 is important, there is a total solar eclipse somewhere on Earth. So yeah, if you by chance miss this eclipse, don't worry. There is going to be a next eclipse in about 18 months. I think it's at 18 years. 18 years from this is not that nice, and more like the 18 months. But they had predicted pretty well. There's other total solar eclipses. You might have heard some that they happen every like 300 years. That's more about like the chance of the eclipse happening in the area you're in again. Like if you're in Austin, the chance of another total solar eclipse happening in Austin won't be for another, let's say, about 300 years or so. And yeah, so kind of also really cool thing with eclipses, they're really useful for science. So there's an element you might have heard a lot about, especially if you go through to a lot of birthday parties, which is helium. So helium's a gas and was actually discovered on the sun during a total solar eclipse back in 1868. So several astronomers around the world were analyzing the sun's light. So in astronomy, we have some instruments known as spectrographs. So these are instruments that analyze the light that we get from a star or a planet or a galaxy and comes back as a rainbow bar, the visible light spectrum. So let's say you have your visible light spectrum and you get a lamp, your rainbow bar, you get a lamp filled with gas, let's say hydrogen gas in this case, shine a light through it, then look back at your rainbow bar. You're going to see some black lines, some pieces missing. This is known as hydrogen signature. Every single element, ion, molecule has its own unique signature, its own unique pattern. So we get a ring of a star like our sun, we can get this pattern. And depending which lines match up, can give us an idea what element is inside this star, this planet, or this galaxy. So as you can see in the image, we got the spectrum of hydrogen and some spectrum of helium. And for these, they had known about the hydrogen one, but the helium one they didn't recognize. They They during an eclipse, they point this instrument at the sun during the eclipse to get enough light to get that reading. And the astronomers realized that they were getting a new pattern, like we discovered a new element. Some of the astronomers did were like George Riot were ones, and some other astronomers around the world also kind of got the same thing. So kind of two sets of astronomers got the same thing at the same time and were able to kind of meet together and go through it. Actually, lots of the big astronomers at the time were able to get these readings and confirm it. So they found a new element. They saw it in the sun. And the way kind of helium got its name is, Helios is kind of considered to be one of the gods of the sun. Now this is the element helium. So that's one of the ways they were to kind of do science with the sun. Another cool thing is they actually helped get more data that gravity bends light. So there is a theory that gravity can bend light. So the way this works, imagine you have a blanket that's stretched out really tightly. This is going to be our fabric of space and time. In this case, kind of literally our fabric. You get a marble. Let's say your marble is light. You get your marble and you shoot it across the blanket. The marble moves in a straight path. Light moves in a straight line. Now, let's say you put a baseball on that blanket and you shoot the marble again. The marble is going to bend a little bit. The baseball bent the marble, mass bends light. So to kind of get this going, actually some astronomers decided to test it out. So what they did is in the early 1900s, they kind of looked at the position of some of the stars. So they have they saw the position. Actually, it was 1919. Frank Watson Dyson and Arthur Stanley Eddington. They looked at the position. They yes, like Buchanan is back. They looked at the position of the stars. Then they checked up again 6 months later, and when the eclipse was there, and checked again. And it looked like the stars had moved, but the stars didn't move. There's now just something very massive in the way, blocking out some of the sun's light. Also, we can use eclipses on a smaller scale to help us find planets in other solar systems, using what we call the transmit. Oh, and here we have a cool clip of a coronagraph. So basically, what I was showing here is, and the kind of the eclipse picture of the eclipse there from a solar eclipse in Hawaii. There, that the room's blocking out the sun, and you can see the sun's corona. It's outermost and dimmest layer, which is so dim you can only usually get if something's blocking out the sun's light. So we were to analyze the corona, want to go more in depth into it. We can use what we call a coronagraph, a little disk that blocks out most of the sun's light, lets us see the corona in motion, and lets us see things such as solar flares and coronal mass ejections, which is why that camera got a little static. It got hit by one of those huge bursts of energy. Not only is a light released by a flare, but charged particles also get released. And also, as I was saying, we can use it to detect planets in other solar systems, using what we call the transit method. So we have our star. We know how bright the star's light is. So if something passes in front of the star, it'll block out some of the light, decrease the brightness. And that keeps on happening. That means something is orbiting the star. Depending how much light gets blocked out and for how long it gets blocked out for, can give us an idea of the planet's mass and its orbit. So we can actually find these other planets around other stars. There's some other methods kind of using light, but it's one of the ones that kind of comes to mind when we're talking about eclipses. So yeah, about let's switch back to some of the big views of the telescope. Ooh, so it's kind of McDonald Observatory one. We're getting close to that point of max coverage. That will be at about 1:27, so a little under 20 minutes or so. And when we'll get this little sun's light, well, the moon full blocking out the most it can of the sun's light, about 91%. But at about 1:37 is when the one in Lake Buchanan, Austin, when they're going to start getting their total solar eclipse. So we're getting closer and closer to the peak of the program. Well, it's going to be fun. But yeah, so kind of before we do that, I'm so kind of going to step away for a bit. Also check out how the sun's behaving outside, and hopefully the weather's still holding up. See more of the sun's light being blocked out. Again, make sure to have your viewers. If you want to make your own pinhole viewer, just rewind a little bit earlier. about 20 minutes earlier. I have a little schedule. Basically, every 20 minutes, I'm jumping in and talking something Eclipse related. And I'll be back around 1:20 when we're getting kind of closer to that peak. And I'll see y'all in a bit. Welcome back, everyone. So now we're getting half close to the point of the tally. Welcome to the McDonald Observatory live stream about the 2024 total solar eclipse day, and we're getting close to showtime. So we currently have some. So if you're just joining us, welcome. My name is Sol Rivera. I'm one of the public program specialists over at the McDonald Observatory and help run these live streams. Currently, we are located out in far west Texas. So the blue star is where my colleague in Austin currently is. The telescope's currently having some technical issues, but we're able to get some nice live views from there, and hopefully able to get some views kind of there in the future. The orange star is McDonald Observatory, where some of my colleagues are currently at, and we're getting this view of the sun. So this is from a solar telescope over there on site. It's will be reaching its point in just about 5 minutes, about 91% of it. So you're seeing the moon it's getting close to devouring more and more of the sun's light. If you've been outside, you might be noticing the light getting dimmer and dimmer and dimmer and cooler. Even if you're not in the path of totality, you can still notice some of these kinds of things. And yeah, kind of going back to slideshow again. The green stars where I'm currently at, it's Irving, Texas. So we'll be getting our peak here and a little on like 17 minutes or so. It's getting close. It's getting close. And I'll be switching over to my phone once we get to that, so you can actually kind of see a bit of that, which is going to be really cool. I'm really excited. Kind of hopefully we can show a live view because I'm going to be outside to see that total solar eclipse. It's going to be super cool. But yeah, kind of going back over, here's kind of along the path of the total annular eclipse one from 2023. Those of you kind of in the lower parts of Texas might already be getting to that point of totality. Of those of us in upper Texas, will be a couple more minutes, but it's getting close. Oh, and that was going to be kind of me, so re-explaining a quick recap of how to press the wrong button. Recap of how eclipses happen. They happen as the moon's making its way around the Earth. It blocked the sun of the light. So to break down how orbits happen, we're going to break down a bit of gravity. So if I drop a pencil, it's going to fall to the floor. And before we can understand eclipses, talking about the moon and gravity. So we have a little friend holding a ball. He's going to try to throw it, or better in this case, first he'll drop it down, but he's getting kind of close to that point of totality. So kind of here we have a little friend with a red ball. If he's going to drop the ball, the question is, where will the ball go? Will it go straight through? I will, but it's going to come back up later on. So as the ball falls, it doesn't fall just downwards, it falls towards the Earth. So if friend number one drops the ball, it drops to the Earth. Friend number two drops the ball, doesn't fall downwards, falls towards the Earth. And same with friend number three. It's going to fall towards the Earth. So if friend number one decides to throw the ball, or actually here we have both friends are going to drop the ball to the center. Eventually it's going to go to the center. And here we have friend number one, who's going, and sorry, I'm just excited about that it's getting close to that totality. But friend number one's going to kind of hit the ball. It's going to move a bit, then fall towards the Earth. If he hits it harder, it's going to fly a bit further and fall towards the Earth. He hits like harder, goes even farther, but still falls to the Earth. But eventually, you can add such a strength. He's going to hit so strong that it's going to keep on going and keep wanting to fall towards the Earth, but it's going to keep on missing. And that's what's making an orbit. So it's basically an object that's going around another object, and it keeps on falling and missing, which becomes the orbit. So what the moon is doing is falling towards the center of the Earth, and it's missing, which is very nice. It would be very bad for us. And what the Earth is doing is that's falling towards the center of the sun and also missing, which is also nice. So we know the moon orbits the Earth, including planets and asteroids and such. And sometimes things can line up just right that the moon blocks out some of the sun's light and gives us a total solar eclipse. So kind of in this little video here, I've shown it earlier. It's big screen net. So we have the moon's blocking out sun's light as a shadow goes across the Earth. If you're in that really dark spot, it's where you can get that total solar eclipse, that totality going on, which is what we're really excited for today. If you're not in the very dark circle, you're going to get what we call a partial eclipse, which is what the observatory is having right now. And actually, speaking of, it's currently at its max. So since the observatory is outside the path of totality, you're not going to have the entire thing be blocked out. But right now we're getting about 91% of the sun's light being blocked out by the moon. So if you're there, you're noticing it's a little bit dimmer, you're going to notice it's going to be a lot. It's just getting darker and darker. It's going to be so cool. But the one we are excited for is the total solar eclipse, which is happening in some areas as I speak, which is really exciting. So the moon's completely blocking out the sun's light. And so kind of like in this view here, when it starts revealing itself, a small light might shine through. To look at the eclipse, make sure you have the right equipment. You can project views. So as like, oh, I think it's actually at the peak now at the eclipse. Oh, yeah. And I think there's still some clouds going through, but oh, that looks so cool. But going back to actually seeing the eclipse, because it's getting to showtime about, is so there we have the moon. There we have not the moon. Well, the moon technically is kind of there, but in this case, we have the sun's light coming in through the red telescope and projecting the view onto a piece of paper. Actually, with this, when you focus, you can see sunspots, darker areas of the sun. Then the other telescope there to the side has special filters in front. If you're looking at the sun with a telescope, please do not look directly into the telescope in the eyepiece. The light's being focused to a point, and that will really damage your eyes. So make sure you have the right filters on there. Also, make sure you have the right solar viewers or eclipse glasses. You can also look at also indirectly with the pinhole effect. So actually, earlier I showed a little cutout we had made of a cat, or at least a colleague had made of a cat that has a pinhole effect going on. And you can actually see, as I zoom in, that effect. So here we got the actual cat itself. And if you look at the cat's eyes here, as I kind of scroll on down, you can see little crescent shapes. It's like the cat's getting really sleepy. You can do that pinhole effect. You can also make one with a zero box. I showed a little bit earlier how to do that. So if you want to see how you can just turn back a little bit, that'll take probably like 5 minutes to make one, which is very well worth the time. And also you can just, if all else fails, use your hands. If you kind of do kind of like a net effect with your fingers, the opening you make through that can actually give that pinhole effect going on. So even though the gaps are making like trapezoids and triangles and squares, if it's small enough, as like it'll be a circle, or during eclipse, you'll get that cool crescent shape. I was kind of showing from my slides here. Like you can see here in NASA how all the holes are kind of little crescent shaped ones. And also the really cool thing I'm excited about this one, you're going to see planets during this. If you're in the path of totality, you're going to be able to see Jupiter, Venus, Saturn, and Mars in line with the eclipse. They look like bright, not twinkling stars. Which reminds me, you gotta see where it is. Let's see. Oh, a colleague of mine is wrong slide. Colleague of mine is joining on in. Let's see. The video on. You can try to show me a live view going on. Let's see. Yeah, but yeah, my colleague over at Austin, he's going to kind of set up his camera so we can actually see the eclipse as it's happening for him live. And he'll message me once that's ready. The telescope has been acting up. That one over there. So, oh, looks so cool. just a few more minutes for me. I'm really excited about that. Also gonna set up my phone to actually view that once I'm actually out there. It's gonna be very it's so cool. I can't wait. But yeah, the well, it's the tell the full will begin over at Lake Buchanan in just about 4 minutes. It's gonna be so cool. You're gonna notice the light getting dimmer and dimmer and dimmer. Actually, while he's getting that set up, uh, my colleague did send us pictures of his view, which I'll be showing here. See, that's currently what his view is over in Lake Buchanan. So actually has been dimmer than when he began. Even here in Irving, it's getting dimmer and dimmer. And family friends visiting did say that's actually feeling a lot cooler for her. And oh, it's so excited. Let's see. Oh, my colleague's getting his camera set up. Oh, that's gonna be so cool. It's gonna give me the go once his camera's nice and ready. Really hope his camera doesn't mess up. You know the things we do for science. Let's see. Oh, it's getting close to that point. Oh, it's gonna be nice. Let's see. Give me a thumbs up if you're ready for me to show your view on the live stream. Let's see. I'm going to assume he is ready, so I'm gonna full screen that. Okay, yeah, hear me. We are ready. Ooh, that's gonna be cool. Screen my colleague's view over at Lake Buchanan. You can see how the sun's light, like it looks weird, like it looks kind of like dimmer, like the sun's dimmer than usual, getting darker and darker, getting to that point. Ooh, that's gonna be so cool. Yeah. Oh, that's gonna be so cool. Things getting. Oh, you see, you can actually see the sun getting dimmer and dimmer and dimmer. Oh, that's so cool. Ah, ha, ha, ha. Oh, that's not. Oh, that's so cool. See, it's like it's almost like the end of the day now, but it's not. It's just the moon's now in the way. It's gonna be so cool. We're gonna be just a few more minutes. And for me, my full begins in about 5 minutes or so. Oh, that looks so cool. Yeah, since you're getting good, getting some pictures ready, which they really should. This is a time to take pictures. Even you can kind of see a little bit of the. You can actually see the circle of the moon blocking out. Oh, and you can see. Oh, you can see planets. What looks like a little star. That's one of the planets. Ah, ha, ha, ha. Oh, that's so cool. I think that one's Venus. That's probably Venus more than likely. Oh, that's so cool. Yep, that's Venus. Oh, that's so cool. Yeah, no, if and the little one should be Jupiter. Oh, that's yeah, and if you know where you're looking at, you could probably like got some binoculars going. You probably see Saturn and Mars as well, which also reminds me to grab my binoculars when it completely covers Earth because it'd be so cool. Ah ha ha ha. Oh, and that's my weapon. Yep, I actually joined in there. That I didn't expect for me to pop up so soon on there, but that's so cool. Oh, that's so cool. Just in awe. Oh, that's so cool. I'm just geeking out so much right now. Oh, there's fireworks. Oh, that's a cool thing to do. Oh, that's so cool. Some little by little, it's gonna be blocking on out. Oh, it's already starting to unveil it, so it's getting a little bit brighter. Little by little. Oh well, that's going on. I'm gonna switch, kind of prepare myself outside, and probably by the time I'm, oh yeah, since like, oh yep, a little bit. Oh, that looks so cool. Yeah, I'm gonna be setting myself up outside to get the Irving view. I'll be back. ¿Cómo? Pues todo rápido que está bien. Hello. Yep. So this is gonna be one of like the live view for me and Irving in a bit. You can see the one for Ryan still going on, going on. Oh, it's gonna be so cool. You can see it's darker. Also got family and friends here as well. It's getting darker, darker. For Ryan, it seemed to ended on Ryan's end. Now it's for me as we're gonna see this. It's about to start, so I'm gonna mute myself on here and enjoy the show. Was so cool. Chills. Chills. That was so cool. I hope y'all are enjoying this as well. I'll jump back in a little bit to talk more about have more eclipse stuff. But I'm gonna go back out and enjoy the cool views. So I'll see y'all in a little bit.
Yo tomé una foto con mi teléfono. Tres minutos y medio. 3 minutos y medio. Lo que pasa es que las casas empezaron a prender las luces. Como que ya es de noche. Sí, madre. Y cómo apagaron las chingaderas. Pero sí, tomé un videíto, pero uno chica como ayer me ven cabrón. Hagamos. Pero como sí, sí. No, yo voy para allá. Me vine a la casa. Son las, son las 2. Aquí saco. Órale, pues. Está bueno, ahí estamos. Sí. Sí. Sí, no, rato ya queremos salir de esto. Yo tengo que agarrar el camión. ¿Verdad? Sí. Sí. Vale, pues. Ahí estamos. Vale. Ok.
Mira, puso todo esto, porque aquí está viendo todo lo que está pasando allá. ¿Y aquí qué es lo que está aquí atrás? No, pues nada. Este es mi cuarto, nomás que pone esto para que aquí se vea esto. Y aquí él trabaja hoy, nada más. Mi amor, ahorita te algo de comer. ¿Tú sabes que era mi hijo? Tenía algo que me parece que el otro estaba como así con tu primo. No, con mi hijo, ¿verdad?
En el programa de Lauristas, escucha las voces de mi TXK, en el programa de Lauristas están platicando, ¿verdad?
Was so cool. Yep. So welcome to the observatory live stream. So the eclipse has already passed through Irving, but it's gonna keep on making its way on up north. So it's gonna be a bit so kind of going along the path. So the next areas it will be hitting on up will be well kind of right now. A bit of northern Texas probably getting a bit of those views. So currently next on the list in terms of big city, just past Dallas, is going on over into little bits of Texarkana and Oklahoma. It's gonna keep on going. So I hope every the weather in the other parts of the U.S. are complying. So with the one from Lake Buchanan from my colleague, he actually said that they had complete cloudless skies. Then just there's a opening in the clouds making its way over to them, and you could kind of see the kind of in the little gap. It just lined up just right. It cleared right before the eclipse, and now it's completely cloud over for them right now. It seems also might be a case back at the observatory. They might be having some clouds as well, but you know what? It lasted for the amount we needed. And over here, I thought I had muted. I'm pretty sure I had muted myself, but in case I did not mute myself when I was sharing the view from my phone, you could probably hear the hooping and hollering from my end. Also, the dogs started barking. Toddlers started running around like crazy. The security lights turned on for the neighborhood, like the ones that automatically turn on a light. And we were able to see Jupiter and Venus. I had brought some binoculars with me, but I didn't remember where I could put them since I could not put them out for the eclipse. So, oh, that was such a cool event. Oh, it's gonna be so cool. So again, so we're just showing in this the McDonald Observatory live stream. So now that we've kind of reached talk about what to expect next. Like people ask, well, when's the next eclipse gonna happen here? Oh, also before I forget, my colleague also did share Lake Buchanan. So kind of getting an idea of the before and after. So this is how it looked like at about 1:10, I believe. I know he put the timestamp on there. Yeah, 1:15 is how it looked like at 1:15. And how it looked like basically during that totality. It's like basically 9-day difference. Even here, it's like, oh, so cool. But yeah, what to expect next is where the next eclipses are going on. So as I mentioned, kind of like they found that very early on, the eclipses happen like basically like around like every 18 months. And like every 18 months or so is when eclipses happen here on Earth, when we can get a total solar eclipse. So next one coming on up will be in 2026, actually cutting through Greenland and Spain, and I believe also Iceland. Let's see if I can get that map pulled up. I thought I had it already open, but seems I had accidentally closed it in the eclipse kerfuffle. But yeah, the next eclipse will be going through Spain and Greenland. Then there will be one after that in Australia. And next one here in the US won't be till 2045. So it's going to be a good wow. Oh, that was just so cool. I'm so geeking out about that. But yeah, the next eclipse here, kind of part of the reason why people are so excited about it happening here in Texas is just we won't really have like another eclipse here like in Irving or in Dallas, or if you could say Austin, for like about 100 to 300 years or so. So that's why this was so exciting. But again, if you by chance did miss this one, they do happen elsewhere in the world. And they like, so again, like if you're fond of traveling, might be worth going check out the next eclipses going on. So again, there's like the one in August, and I believe it's August in 2026. There's also one going through Australia. I might go to that one because I've personally been wanting to visit Australia for a while now. And it's gonna be so cool. Let's see. And yeah, just have I do know numbers are dwindling. Some of you are kind of starting to travel. We'll also give some heads up for those of you that. Thankfully, this has been my second eclipse. I've been lucky enough to this to be my second one. Uh, do keep an eye out on that traffic. Even on the way here, I saw many signs saying arrive early, leave late. Traffic right after eclipse can be chaotic, so may be good to stay indoors for a little bit, wait for stuff to kind of calm down a little bit. But yeah, no, and let me get this map pulled up. So here's from over at Great American Eclipse, which they also kind of, I believe they also did give the stream a shout. So thank you so much, and thank you for helping out with being on the front of informing people about eclipses. But yeah, no, here we have a map of some of the upcoming eclipses over the next couple of years. So we also got some annular eclipses coming up. Those can be really cool effect. We call the Ring of Fire, which is also just really cool to see. You get a kind of little effect going on. So yeah, the next total solar eclipse, there's going to be one going through, as I said, like kind of Greenland, Iceland, kind of Spain. Actually, seems a little, yeah, about Spain through August 12th, 2026. Will also be things lined up right for August 2027, August 2nd, kind of going themes through parts of Africa. Then also one 2028 going through Australia, and 2031 kind of going through Australia as well, and parts of South Africa. And there was one a few years ago we left in the Arctic, but I don't know if they got that there. If they did, that must have been awesome to see. I could just imagine glaciers and seeing the eclipse. I wonder if they might have had Northern Lights as well. If they did, that would have been so cool. But yeah, if sadly, if the weather did not cooperate to you for this eclipse, I still hope you were able to enjoy like the sky darkening, temperatures dropped even for us. The moment that it was like 99%, you just felt that chill come into the air, and it just was like dark. Basically, it's like nighttime. It's so cool. But again, if you by chance miss this eclipse, there are several other ones going around throughout the world. Next one you guys will be 2045, so you can wait around then. But again, if you want to travel, might be cool to check out some of the other ones. So we are kind of reaching towards the end of the program, but there will be some other things I'll kind of talk about. So it kind of seems the observatory one's kind of slowly coming on back. We switch over to a white light view. So let's put on the big screen. What you're seeing right now is some of the behind the scenes, the actual controls of the telescope. But yeah, so kind of saying we're kind of reaching the end of the program. So while we're doing a little bit, I'll jump back in, talk about the sun itself, just kind of seeing if we can explore bits of the sun here and there, see some cool views. Even if we can't get live views there, I do have backups. And I really hope y'all were able to enjoy this event and stick around to see more stuff going on. Welcome back, everyone, to the McDonald Observatory live stream. So, thank y'all for that been kind of joining us, sticking around with us for this stream and for this event. We are kind of dwindling down a bit, so kind of we're going to start focusing more to like the sun and what we have been talking about the sun, but kind of shy away from eclipses and just other cool aspects. But before I kind of explore the sun, kind of see some cool views and different lights and wavelengths, do want to share some cool live views some of my friends have taken and actually sent along and gave me permission to share. So this one here is taken by my friend Spencer Williams. He's singing just outside of Chicago. By my friend Saad, not me. He was in Plano, Texas. This the pics he got of the eclipse. Oh, it's so cool. Then also, that's the Chicago one. They also was taken by another friend of mine, Celeste Alvarez. She's also in Texas, and these are the kind of some pics she got. This one looks so cool. Oh, it looks like a wallpaper. And also another one submitted by another friend that his mom took. So to Christine Clark that she got while in the layover in Dallas. That looks so cool. Almost looks like straight up a sci-fi movie. And sun is cool. Eclipses are cool. Science is cool. Astronomy is cool. It seems the weather have come back in for the telescopes at the observatory in Lake Buchanan. There did seem to be like some attempt at clearing over there. And yeah, so that seems a cloud squad though, but I did say we have backups, so we're going to be talking more about kind of exploring the sun together and such. And these are actually some resources that you can access as well. So let me just get those pulled on up. But there it goes. So one website that we kind of use a lot, and it's a really good resource, is spaceweather.com. So you can see they have a real-time eclipse photo gallery going on, seeing like the time of the eclipse in some different cities around the world. And another thing as well is this daily picture of the sun taken by Solar Dynamics Observatory. So currently says the number of days there's been without a sunspot throughout the year. We're reaching a solar maximum, so it's basically a sunspot almost every day. And you can see a a lot nicer image of this. So I'm going to click on no labels so we don't get the labels. And ta-da! You may not be that impressed, but which is totally understandable, but this is the sun. You usually think big ball of fire, stuff flying all over the place, not that weird bumpy looking grainy ball. But this is how the sun looks like, at least to our eyes. So this view is what we call a white light view, the type of light our eyes can get. So we could look at the sun and not be blinded by it, kind of like today. You could see this. So those of you who are looking at the sun through solar telescopes might have seen a view like this. There might have been variation in color. Some might have been black and white. Some might have been more reddish orange tinge. Depends on the filter. But this is just your regular white light view. This kind of more accurate to the sun's color, which is sun's a yellow white star. And then also some just checking the messages because another friend said that they also got a video of the eclipse as was going on. So I'll pull that up once in a little bit. But so kind of here there, I kind of want to point out this white light view for the time being. So one thing you might notice is there seems to be like a weird texture to the sun, almost like a grainy texture. So if I zoom in, you can notice that a lot more. We call this granulation. That's how the sun surface looks like. And this granulation is actually caused by, it's so kind of if I get, well, before saying what it's caused, let me zoom in a bit closer. The way this moved might seem almost like bubbles. So that's because they kind of are. So what's causing this granulation is what we call convection. Stuff on the bottom heats up, rises to the surface, releases all the heat and energy, cools down, and repeats itself. So each of these granules are basically giant bubbles, each one almost about the size of Texas. And you might also see this dark spot going on here. We call this a sunspot. A sunspot is an area of the sun that's slightly cooler than the rest of the surface. If you're inside a sunspot, you'd be at a chilly 7,000 degrees Fahrenheit. The really dark part of the sunspot is known as the umbra. The not as dark part is known as the penumbra. Umbra meaning shadow in Latin, because when people first saw these, some thought there were mountains and clouds casting shadows on the sun. We know it's not true anymore, but the name stuck, which is actually a very common thing in astronomy. The ways these are created is that the sun's magnetic field is very chaotic. It does go from North Pole down to South Pole, but because of the way the sun spins, it goes through what we call differential rotation. Different parts move at different speeds. So the equator takes about 25 days to complete one rotation. The poles, though, take about 35 days, and that can get the magnetic field all tangled up, kind of entering and exiting at different parts of the sun. As the magnetic field loops around, the area it goes into will kind of interrupt the bubbling, the convection, causing it to cool down and create the sunspot. And even though the umbra seems super dark, if you, let's say, plug it out, put it into the night sky, it'll outshine the full moon by almost 100 times. The reason it looks so dark is that the rest of the sun is just that bright. Actually, a comparison are cell phones. When you're indoors, you can see the screen just fine. But when you step out into the sunlight, you can't really see your screen that well anymore. It's that competing light on a lot bigger level. And to get an idea of how big these are, this sunspot probably around up here is getting to about the size of planet Earth. These things are huge and actually grow and shrink over time. They can last anywhere from a few hours to a few weeks. You can also look at some bright areas of the sun. So we call these solar faculae. Sometimes the sun's surface can part a little bit, and then heat and energy from lower levels can seep on out. So you can say these are kind of like temporary cracks on the sun's surface. See, ooh, more videos getting sent over to me that I can show off. Well, that could kind of get sent along. So again, this is a pretty recent image that's taken almost like every day, almost like every morning by the Solar Dynamics Observatory. And this is a really cool view, but I may be wondering, well, where's the fire and stuff? You're seeing pictures and videos. Well, to see that, we just look at a very specific wavelength of light, kind of the one we're using for the McDonald Observatory telescope for a while, the H alpha or hydrogen alpha. Since the sun is mostly made of hydrogen, we can see this hydrogen gas moving around. Before we switch on over to that, though, let's see. There's going to be a video sent to me. Let's see if that's been uploaded. If not, we'll definitely show it off because it's always fun showing off those kind of things. But so switching back to the sun, so for the H alpha view, there's a website I really like to show off, which is this one, H Gong Alpha, the NSO, National Solar Observatory. Am I saying that one? Yep, National Solar Observatory. And you can get it very easily. Just type in H Gong Alpha Solar Telescope, and you can see telescopes around the world. And solar telescopes around the world, better yet. They can actually choose which telescope to do. So they can say when the picture was last taken for this. So Chile was taken about 3.5 minutes ago. Big Bear about 4 minutes ago. Hawaii should probably check up on their telescope. But you can see this really cool view of the sun and that H alpha view. Right away, the sun looks really different. You don't see a grainy texture anymore. You're seeing more of a wavy pattern. That wavy pattern is a hydrogen gas going on, which actually, if you're wondering if this actually looks like, this is how it's looking like from the McDonald Observatory telescope. You can see it basically matches up. Orientation's a bit off, but it's there. So you can see kind of that the sunspot from earlier. Seems like Buchanan telescope has disconnected. So that's they were having lots of technical issues. But they let's see, kind of like no. So you're gonna see a grain texture more, so you can come more of that wavy pattern going on. That's a hydrogen gas I was mentioning. The really bright areas in this wavelength are what we call solar plages, solar beaches. There are areas of the sun that are hotter. Basically, there's a bit of energy. It gets hotter and brighter and brighter in this wavelength. It kind of looks kind of like that, kind of like these clouds in the sun, are what we call solar filaments. See, there it goes. There's my mouse. So these solar filaments, which basically is material leaving the surface, looping around, and going back in. And you can see some here in the corners. These will look like, so actually if I zoom in more, I can see a better view. Kind of like the filaments kind of looping around. And the clouds on the edge are the solar prominences. Sometimes the sun's material leaves the surface, loops around, goes right back in. Everything I said the same thing twice, you're right. Turns out solar filaments, solar prominences, the exact same thing. The reason they have different names is that we thought they were different things. We know it's not the case anymore, but the names stuck, which is, again, common thing in astronomy. And to get an idea of how big these are, this fuzzy layer around the edge of the sun is what we call the spicular layer. It's about half a planet Earth tall. So the prominence we had here, and here's a specific wavelength we're looking at angstroms, if you're by chance curious. Here's this solar prominence here is getting to, I'd say, I can actually use mouse for measurement. That's about half a planet Earth, a little circle on my mouse. 1, 1.5, 2, 2.5, 3, 3.5, 4, 4. Getting to about 5 times taller than planet Earth. These things are huge, but they move very fast. You look back at the sun, let's say, next couple of hours, and this might be gone, or better yet, tomorrow might be gone. Also, a fun fact, to actually nickname them after plants. So we have a tree prominence. This one might be more like a shrub. This one could be a mountain. Not sure if that's the actual name or of one, but we're cloud watching on the sun. And a cool thing about the H Gong alpha side, which I really like, is that you can actually get a time lapse of the sun. So we hit this play button, and we're here. We can see how the sun has been moving over the past couple of hours. And you can see that filaments kind of wisping around like this one here. We saw a little bright of burst over here. Like that one, that might have been like a baby solar flare maybe. And this is how it looks like over several hours. And again, this is completely open to whoever wants to access it. And just H Gong Alpha Solar Telescope for this one, spaceweather.com for the other one. Ooh, it seems we're getting a view back from over here. Let me just readjust some parts of here. Since the Lake Buchanan had disconnected, gotta readjust here real quick. So let me do that right quick. There it goes. And just gotta move it around so it's no longer blocking my face. And since Lake Buchanan has disappeared, we'll go with this. But yeah, here we got the view from the McDonald Observatory again. Bit bright. They probably increased the exposure to make up for the clouds are going in and out. But this is kind of a scene. Kind of as you notice, the moon has been slowly receding away from the sun, so less and less light's being blocked out. And some friends have sent me their videos of the sun, and I have been given permission to share these. Let me just pull that up. These open new links, so easier if I pull them up through here. Up. The videos are loading, so with everything going on, it's getting a bit on the slower side, but let's see. But for the time being, going to show off this really cool picture taken by my friend Zach McDonald, which is, well, not McDonald, Zach Donald. But this looks so cool. It looks, oh, it's so pretty. Yeah, but Zach saying McDonald's, so he's McDonald Observatory. Yeah. So cool. Let's see if the video has loaded. It's still loading, but we will be returning a bit. Fred, Greg Bolkel sent me this one. He was an awesome when he took this picture. Eclipses all around. All the eclipses. Yeah, so I'm gonna drop away for a little bit. Come on back to kind of wrap things up. Kind of see if they like some more videos and such, and then kind of wrap up the stream. But again, that'll be in about 5. I'll come back up, kind of do a quick review of what we've gone over, and I'll see y'all in a little bit. Welcome back, everyone. If you're just joining us in, this was the McDonald Observatory live stream. We have spent most of the stream talking about eclipses, how they happen, how to see them, some cool history and science stuff related to them. Got to see the actual totality from the maximum of Austin to Lake Buchanan, Lake Buchanan near Austin, the McDonald Observatory, and then here at Irving, Texas. Let's see. Now, also speaking of views, we do still have a live view from the telescope over at the McDonald Observatory. There is some cloud cover coming in through, but again, this is a live view of that telescope. And yeah, and have to recap a bit of the stuff today. So if you're just joining in or kind of want the wrap up summary, my name is Saul Rivera. I was one of the public, or am not using was, I think it's in the program, but I'm one of the public program specialists at the McDonald Observatory over out in far west Texas. And to kind of let me get you a little map going on. So the orange star is where the McDonald Observatory is at, very far out from main base in Austin. The blue star is like Buchanan, kind of where my colleague was. The telescope started acting up a lot, so they could no longer get a feed. But we were able to get a nice feed for a good while and a live view as the eclipse was going across. And the kind of where the green star is, where I'm at, the Dallas, Irving, Texas. So I do realize it's more towards the left side of Dallas, but on this map at least. But we're close. We're still in the path. And the McDonald Observatory is a research center out in far west Texas. I work specifically at the visitor center, so this building here. We do lots of public programs. We have been getting people from all over the world visiting us this past week, from Germany to Dublin to the UK to California. Very exotic lands to me. And we are open today as well. Actually, two of our staff have stayed behind, and two program staff stayed behind, several other staff stayed behind to help kind of share this experience with those who aren't able to travel to the areas of totality. They get about 91% coverage while there, and we are usually open from there Tuesday through Saturday from 12 to 5 p.m. Some of the programs we do is guided tours to the telescopes. Actually, to one of them is in the telescope in the background, the 107-inch Hardin J. Smith telescope, which was built in the 60s, and actually was one of the ones that helped find out how far away the moon was to an accuracy of about 4 inches, and nowadays about half an inch. And we do a guide tour there, kind of showing the telescope up close. If there's no work going on with the telescope, taking it to the dome floor, maybe you can try and move some things around. And also, we do solar viewing programs. So the live view we're getting from McDonald Observatory is from a telescope we have here at the visitor center. If weather permitting, we show live views through this telescope projected onto a theater inside the visitor center. Here's more information about the specific telescopes we are using in case any of you were interested. And also, we are very known for public star party programs. Usually at about 3 times a week, usually Tuesday, Friday, Saturday night. We set up telescopes of varying sizes, pointing at different objects. They can be either the moon, planets, galaxies, nebulae, star clusters. What is available in the night sky is nice to look at, and you can come visit us and look through there. If you do visit, we recommend making reservations on our website, McDonaldObservatory.org. One other thing I kind of want to show off, a friend sent me a video of her view of the eclipse. I hope this the sunlight was being blocked out. Oh yeah, this one is loading properly, so that's good. And I pull that up. So it's by Cedes Alvarez, and she is currently in our area of Texas. And this was basically what she recorded basically at totality was approaching. So you're seeing the little sliver getting blocked out. It's like more, it's getting darker and darker, more and more lights getting blocked out. It seems like it was like through an eclipse viewer, it seems. It's just a teeny little bit left. Ah, that's so cool. Boop. and it's gone. And then remove the viewer, and bam, the sun has disappeared, or at least most of the sun. You can still see the corona, really bright area around it. Ah, that's such a cool view. Oh, that's so cool. I'm just geeking out. Ah, so cool. Ah, thank you so much to everyone that shared these videos and pictures with me. It's always so cool getting to share more stuff like this. But yeah, kind of wrap on up the stream. I'm really glad all of you were able to join us today for this really cool celestial event. It's always cool seeing more people get into astronomy. We do these type of live streams pretty frequently, but about once every month or two. We are planning to do one towards the end of May next month for the birthday of the 82-inch Olive Struve telescope, turning 85 years old. And we are helping do a stream from the involving that telescope. Just check our social media pages, so Facebook, Instagram, Twitter, or should I say X, the McDonald Observatory, and those. Also, we have done many of these streams before. If you want to check them out, just go to McDonald Observatory on YouTube, and you can find these past streams. Not only have we done solar streams, we've also done streams about galaxies, about books we recommend, the formation of stars, how to make a little galaxy, some K-12 focus one, how to make a galaxy with glitter and cotton balls and still be kind of scientifically accurate in its kind of setup, and also probably should have cleanup set up to the side, and have even done one from the control room of the Hobby Airplane Telescope, where astronomer Dr. Stephen Janowicki shared some of the data he was getting from the telescope in real time, and you were able to see that data and how collection works and more of the behind the scenes. Everyone just check those out. Just this YouTube channel, McDonald Observatory, and make sure to like and subscribe as well. It kind of helps us know the engagement. If people enjoy these programs, and you subscribe, you can see the future ones. Also, something we didn't do for this live stream that is for the other, usually for lots of the other ones, is having a live chat feature. Usually we have live chat, so you can ask us questions in real time. We sometimes have astronomers come in, and so that's the opportunity to ask them any questions you might have, like what got them into astronomy, their favorite books, some of the research they've done, whatever questions you may have. And yeah, thank y'all so much for joining us today. This is a really fun event and really cool event, and I'm so glad the clouds cooperate. That seems like good chunks of Texas actually got enough clearing to see this, which is very nice, since a lot was very worried about cloud cover and storms. Like, there's supposed to be severe storms here in Dallas area. But thankfully, they stayed away until later, which is very nice. But yeah, thank y'all again so much for joining us. I hope y'all enjoyed this program and can visit these programs again in the future, and that y'all have or had an happy eclipse day. Have for those of you still far up north. May the odds be in your favor in terms of weather. Yeah, thank y'all again for joining us today. Also, here we become friends of the Observatory, Gift Shop Online, Started Radio, has some really cool episodes about astronomy and such if you want to learn more about that as well. Yeah, thank you all again so much for joining us.